Okay, so last time we talked about the simple truss, and then we talked about how we can analyze simple truss by using the method of the joint. So basically, we explore, we disassemble the truss, and we go joint by joint and analyze. Uh, Today, we are going to learn another method of analyzing it, but before that, there's a simplification method that we can use, and that's the zero force member. There's a way that you can go and, without doing any analyzing, say which member has no internal force. So in that case, it helps us not to solve for that member, because we are going to end up writing all those equilibrium equations and eventually find out the force in that member is zero. Some of them you can just do it very easily just by looking at the geometry of the shift. So one way is that if in any joint there's only two members and no force applying on that joint, those members are zero force member. So case number one is that if only in a joint that only has two members, if no forces apply on that joint, those members are zero force member. So, an example of that case, so you might have the truss like that. Like this, and the force is applying here. So force is applying here. That's P. So if you look at that, um, A, B, C, D, E, and F. So I want to go and find the joint that has only two members. So look at here at joint A. How many members is there? Two. No forces applying on the A. Right? So the two members, no forces applying on the joint. So those joints, most of them are zero members. So it's zero. There's no force in them. So in other words, it's just said that FAB is 0, FAF is 0. no force in there. The same if I go ahead and look at the joint D. If you look at the joint D, again, in the joint D, there is two member, no force is applying there. So F DC is 0, F DE is also 0. Because there's no forces is on that joint. Remember, if there was a force there, if there was a force on A or on D, then there was not 0 force. So the first case like that. Now when I want to analyze that, I will eliminate the 0 force member. So I will go ahead and say this is equal to this is going to be equal to this. F E B C under 1. So instead of analyzing the top one, I will analyze this. Got it? So there's one point here. So one point here is not that these are not necessary. It's not that they are there without any use. Under this specific loading, there are 0 member. Under another loading condition, they might not be 0. Okay? So it's not that there's going to be always, I can write this as this. Under that specific loading that I have here, I can say that these two and these two don't have any force in there. If the loading change, they might have a force in there. So when you're talking about the zero force, you're looking at that specific moment. The second case that we have the 0 force member is that if there are 3 members in a joint, and two of those 3 are aligned. And no forces applied on the joint, then the third member is 0 member, 0 force member. So, example this. And then let's do some work. So look at here, joint D. There are three members connected to the D. Two of them are aligned. No forces on the joint. The third one would be 0. So that is going to be D is going to be F in dA would be 0. Is that rule working for C or not? For joint C?
From C to A would also be wait. No, I'm curious.
Again,
It should be.
three member connecting. Two of them are aligned.
Okay, I didn't know if those were coming as aligned.
There is no forces there. The third one would be 0. So F in AD would be 0 at AC. So I can go ahead and say under this loading, under this specific loading, this is equal to simple A E E and P.
This doesn't really apply. Can you remind me what the difference in those triangles are? Because like I know the one has the line that's a space, and that's that's a joint that's not like is not screwed down. Maybe.
Which one? Which one?
So the joints that have the like braces attached to the ground, or like, so like that's yeah, the symbols, they're different, and I know that's because they mean different things.
This is pin.
Yep.
If there's no line underneath, it's just the triangle, it's pin. Pin means that it doesn't let it go left or right, it doesn't let it go up and down. If there's a line underneath, it means that's the roller. The roller doesn't let it to move normal to that, but parallel to that, it doesn't. Yeah, it does. It can move like a tire in the car.
Yeah.
So if it doesn't have, it's the triangle, it's a pin. If the triangle with the line underneath, it's a roller.
Thank you.
calculation. So remember that anytime that you are given a truss and they ask you to analyze it, first look for to see if you can find any two joint member. If you can find it, just uh, get rid of them before actually start um, analyzing. If you don't, nothing happens. You're just gonna do more calculation and eventually you'll find that you're gonna be zero.
We can't remove it if it is a connection point, correct? So like if it has like a pin joint or a roller joint, like,
Because these are the support, so
Yeah.
definitely you have a force there.
okay.
So if you have a force, those
Okay.
rules doesn't apply. So, quick example and then move to the next. So if I have a truss like this, H, like that. And let me do it from there. So if I have a truss like that, which members are going to be zero force member? Before, if I want to analyze that, I can start analyzing like this, or I can go ahead and say I'm going to simplify it first before I start to analyze. So, which members are zero force members?
F, so like the force between D and F would be a zero force.
Why?
Because it is three connections, two of them are aligned, and there are no forces on it.
You're talking about F or D?
Going from D to F.
Okay. So So D is a three member, two of them are aligned, no forces, so the third one would be 0. So that is 0. Which one?
So if that one's 0, would that make FC also 0? Like after you get rid of that one?
So if you, as I said, if it's a 0, you can actually remove it. It's like it's not there. So you can actually remove the FT from there.
FC.
FC.
So if I remove the FT again at the F, I'm gonna have only 3 because FT is not there anymore. So I have 3, 2 of them aligned, the third one becomes 0. So this one is also 0.
PC.
No, because C has a pressure on it.
G doesn't.
I guess, yeah. Yeah.
So joint G is correct. There are 3 members, 2 of them are aligned, no forces applied, so the third one would be 0. So that would be 0 as well. What about H? So there are 4 members, so it doesn't apply. B, there's a force there, so it doesn't matter how many there are. A, there's going to be a force at the A because of the support. E, there's going to be a force because of the support. And C, there's a force there, so I cannot touch those ones. So if I want to go ahead and redraw that, it will reduce to something like this. The A, B, C, and B, E. 2 kilonewton and 5. Now, if I want to analyze it, I will analyze that. So it's going to be much simpler, much easier, and that will work. The question? So last time we talked about how to analyze the truss, and we look at the method of joint, how we can use the method of joint to analyze it. Now, this time we are going to look at another method called method of section. And very quickly, the difference that when we talk about the method of joints, we find the forces in entire truss, in all the member of the truss. If you want to do it, if this is what we want to do, the method of joint probably is the better one. If we want to find the forces in all member of the truss. But what if I only want to know the force in one or two member? So there's too much work to analyze the entire truss to only find the force in one or two members. So this is the method that we are using it. If there is a specific member or members that we want to find the forces only on those members, not in entire truss. Let's first of all, before I started, let's look at it as how the member works. So if I have a member, okay, and it is in tension. If I go ahead and cut it in half, okay, I go ahead and I will cut it in half somewhere there. It doesn't matter where, somewhere I will cut it in two pieces. If I cut it in half, what I'm going to have is the left half and then the right half. It's going to be T on the left end, it's going to be T on the right. If this one wants to be in equilibrium, this wants to be in equilibrium, it means that there should be a T here, and there should be a T there. Correct? So these two are internal forces. I cut it, these two are the internal forces, which in the real world is in there. If I cut it, these are the two forces that are there. So if I have a tension, that's how it's going to look like. If I have compression, it's going to be the opposite of that again. If I have I have a member, look like this. And this starts in compression. And I go ahead and again cut it in half somewhere there. And draw each half of it. I'm going to draw each half. And put the forces there, so the external forces on that member. Then I'm going to have the internal forces to balance those external forces, which looks like this. That's going to be compression, under the compression. So in the method of section, the steps that we're going to take is that the first step, like before, step one. write the equilibrium equation for the entire truss and find the reaction of the support. So write equilibrium equations for entire truss and find reactions of supports. There are cases you might not need to do that. So by practice you will know that which one you need, which one you don't need. But you can say as a general rule, just go ahead and find the reaction of the supports. That's the very first step that you will do that. The next step is that you are going to cut through the truss, or basically split the truss into two sections. So the second step is that split or cut the truss into two sections. So I'm going to split it into two sections, and remember that the section line should pass through the member I want to find forces in those members. So I'm going to split it, but not split it anywhere. I'm going to split it through the member I want to find the force in those members. So split or line should pass through members that we want to find forces in there. The next is that the split line or cutting line or choose cutting line in a way that you do not have more than 3 unknown. In simple word, what does it mean in simple word? Do not cut more than 3 members. Okay, so do not cut more than 3 members.
Is that a specific ratio or just ever? Like, if something has like 100 members, are you still only allowed to cut 3?
Yeah.
Alrighty.
Because I only have 3 equilibrium equations: sigma of x, sigma of y, sigma f. If I cut 4 members, I will end up 4 unknown, 3 equations.
Gotcha.
So whatever you do, don't cut more than 3 members. You don't need to cut it once. So if, for example, you have 100 members, cut 3 of them first, then cut 3 others, then cut other 3, then cut other 3. Depending on which member you want to find forces in them. But make sure you are not cutting 3 at the more than 3 at the same time. The next is that 3 Now, consider all member for this put in internal force as tension in all member all members that are cut. So any member we cut it, we put the internal force of tension on that. Like this. So after we cut it, we put the internal force as a tension on that one. Right? Leave your equations for one of the cut section, one of the section that are called section and find unknown. So it doesn't matter if I choose the left or right. So I cut it in half, I split it in two parts, and then choose one of the section and write the equilibrium equation, find the unknown there. And the unknown is going to be the force in the matrix. So we're going to do the example you see. So any question up to here? Now we're going to show you the example how we're going to do it. So first a quick example we got. So assume you have a truss look like this. That's going to be something like that. 1,000 Newton from here. So assume you're asked what is the force in CG. So I only want to know FCG. I don't care about anything else. Okay, so assume the question is that FCG, how much is the FCG, and I'm not worried about anything else. I don't care. I only want to know that. Okay, so if I want to follow this equation, what I want to do that, I'm not going to solve it, I'll just show you how to do that, then I will do the example with the number, or for this one. The first step is that I have to go and find the reaction of the support. So I will go there and find the reaction of the support, and the reaction of support is that I have dx, I have dx, I have dy. Okay, so first step, I will find these three for the entire truss. Correct? So that's the first step. Just write the equilibrium equation and find these three. Assume we have them. Now I want to find the CG. I only want to find the force in the CG. So I have to go and cut it in half. When I want to cut it in half, is that my cutting line should pass through the CG, and it should not cut through more than 3 members. Right? So this is the sense. I have to cut it through. My cutting line should pass through the CG and not cutting more than 3 members. So if I cut it like this, I go ahead and cut it like this from here. Does it work? It's only passed through this. It cut through the CG and it's not more than 3 members. So I'm going to cut it and draw each half. So first I draw this half. And then I draw the rest. So this is the A, B, G, F, C, and D, and E. Now I will put all the forces there, so I have the external force. I have dx, dy, dx. I have 100 here, also here. And then I will go ahead and put the forces there as a tension. So it's going to be tension. F, B, C, F, B, C. It's going to be F, C, G, F, C, G, F, G, F, G, F, F. So here, sigma fx 0, sigma fy 0, sigma f 0, sigma m 0, it will gives me dx, dy, and ex. After I cut it, here I can choose left or right side, it doesn't matter. Left side or right side, it doesn't matter. If I select the left side, assume this one. Only that. There are 3 unknowns, 3 equations. So I can find these 3 forces if I write it. So for left section. So I just sigma fx0, sigma fy0, sigma m0, and it gives you the fbc, fcg, and ffg. That's a schematic of how we are doing it. We're going to do the example with the number, but I want you to see. Here we do it for entire truss. So first we write it for entire truss, then we write it only for the left section. Now let's look at an example with number. Any question about the process steps before I go to example? Question? So let's look at an example with number. So here we have truss like this. Okay, we have 400. So assume I have this, and I want to find the forces in G, E, G, C, and BC. So I want to find the force F in BC, F in GC, and F in GE. I want to find force in these three members. So first I said I have to find the action of the support. That's the first step. So I will go there. Here I have a y, here I have dy, and here I have dx.
Should that be, oh wait, I miswrote mine.
Okay. So if I write, so for entire truss, So for the entire truss, what I have to do is that I write the sigma fx0, sigma fy0, and sigma f0. So sigma fx0 for entire truss, it will give me dx plus 400 is 0, so dx is minus 400 Newton. Correct? Oh, sorry. There should be AX. That one is roller. This one doesn't have, so this one says. It's gonna be AX. So that's the AX, correct? Next, if I write the sigma m f y zeros, I'm going to end up with two unknown ay and dy, so it doesn't help. So I'm going to write the sigma m 0 at what point? I have to write it either what the a or d because I want to get rid of ay or dy. So I'm going to write it as what the a and counterclockwise positive. So if I write it from here, so I have 1200 times 8 rotating, so the clockwise is negative. Then I have 400 times 3, again rotating clockwise negative, and then I have dy times 12, and rotating counterclockwise, so positive, it's going to be 0. So dy would be, if I have it right, should be 900 Newton. And then sigma fy0, that ay plus dy minus 1200 should be 0. Therefore, the ay should be 300 Newton. I'm going a little bit quick here because we have done this before.
Yeah.
So any question about here? So after I've done that, now I'm gonna cut it. So I have to see which member I want to cut. So I want the force in this one, and this one. So I'm gonna cut those three members. So I'm gonna cut them in half from here. And then I will draw this. I will draw the entire thing, but you don't need, you can either draw the left or right part, the part that you want to use. But I'm gonna draw the entire thing. And then here I'm gonna have here I would have, so I will put the forces there, so AX is 400 this way, AY is 300 this way, dy is 900, and then I have 1200 here, I have 400 here, then I have 1 So now I will put all the forces as tension on the member. Remember, always tension. So it's going to be F, G, E, F, G, E, F, G, C, F, B, C, F, started from my concept. A, B, G, C, D, and E. We have everything there. Now that I have them, look at that left side, I have 3 unknown, right side I have 3 unknown. That's very simple. I can either choose the left, or I can choose the right. Either of one that I want. The book choose the left side, but can do it in any of them that you want. So I'm gonna just so for left side or left section, I can go ahead and start to write the equation. Look at here. If I write the sigma fx0, is it gonna help me with anything? What about sigma fy? Sigma fy can gives me that. But what about the sigma m about either about g? What happens if I write the sigma m about g? Yeah. So if I write the sigma m about point g, these two will cancel. So it's going to be, if I write it out, so these two will cancel. We have only these 3, correct? So it's going to be FBC times 3, and it's going to be positive. Then I have 300 times 4, 300 times 4, negative, and then I have 400 times 3, that's going to be negative 2, 0. So it's going to give me the FBC. If I have it right, FBC should come out at 800. Still, I cannot write sigma fx0 because I end up with 2 unknown. So one other way that I can write it is that if I go ahead and write the moment about point C, if I write the moment about point C, FBC passed through the C, FGC also passed through that point C, right? So they don't have any moment. The only one that has a moment is the one at the top, FGE. So if I write the moment about point C, and look at it here, it's easier. So FGC passed through this, FG also passed through that. So the force is that there is the FG times 3, and the negative. Then I have this one, the 300. 300 times 8. So this one about the C is going to be negative 2. And then I have this 400 about the C, which is going to be 0. Any other forces I have? This passed through the C, this passed through the C, this passed through the C. So only these 2 have a moment about the C, correct? F, G, E, AC come up at 800 Newton. That's it. And the black system, we can write the signal at y0. I write the signal at y0. Then, if I look at here, I have 300 up minus, if I assume this is alpha, and this is the force. That's it, so I can find each component there. It's gonna be cosine or sine. It's gonna be sine. So it's gonna be FGC sine alpha. And the sine alpha you can calculate it from just the sine alpha. How much is the sine alpha? This is 3, this is 4, this is gonna be, so it's gonna be 3 over 5. Right? So it's gonna be 0 sine of, so it's gonna be 300 minus FDC times 3 over 5 would be 0, so FGC would be 500. So this part is what we had before, right? To the equilibrium equation. The only part that we didn't have is just cutting it in half and put the internal force as a tension. The rest is just equilibrium equation. We had it before. No. Any question about the entire process and how we do it? And remember, I can cut any way I want. So, for example, I can cut here. I can cut like this. I can cut there. I can cut there. Any way that you feel appropriate, as long as you do not cut more than 3, any way you want, you can cut it.